Good day, everyone. Welcome to today's section of presentation, and this is by the group 35. And we are presenting on dynamic regenerators. This is our presentation outline, dynamic regenerators and examples, working principles, application of the first law of dynamic regenerators, rotary regenerator, and how it works. Dynamic regenerators, or a dynamic regenerative heat exchanger, is a type of heat exchanger that continuously moves a heat storage matrix between hot and cold fluid streams. So first, one may ask, what is a heat exchanger? So heat exchangers are devices engineered to transfer heat between two fluids without allowing them to mix. So when you talk about the heat exchangers, they are devices which transfer heat from one fluid to another, preventing them from mixing. This separation is achieved by a wall with a high thermal conductivity, carefully designed to prevent direct contact between the fluids while facilitating efficient heat transfer. So, dynamic heat exchangers perform this duty by transferring heat from one medium or fluid to another medium. And what about the regenerative? So, when we talk about the regenerative heat exchangers, also known as regenerators or capacitive heat exchangers. So, all these are names that people use to refer to regenerative heat exchangers. The exchange the exchanges uses a heat storage medium that comes into contact with both the hot and the cold fluid. They are commonly used in power plants, glass and steel manufacturing, and heat recovery systems. A typical example of dynamic regenerator is a rotary generator. Other examples are regenerative heat wheels, fixed bed regenerators, and thermal energy regenerators. Working principles of dynamic regenerators. So heat storage. A rotating matrix or moving medium absorbs heat from a hot fluid. So this rotating matrix absorbs the heat from a hot fluid, which is stored temporarily. Heat release. The heated matrix then transfers the stored or the temporary stored heat which was absorbed from the hot fluid into a cooler fluid. So this happens in a circle, or it is a cyclic process. So the process repeats as the matrix continuously moves between the hot and the cold fluid. So by so doing, transfers the heat from one medium to another. Application of the first law of thermodynamics. The first law of thermodynamics states that the energy or any energy cannot be created nor destroyed, only transferred from one medium to another. And mathematically, it is expressed as change in internal energy minus heat absorbed or released minus work. That means the change in internal energy of the system, heat added to the system, and work, W stands for work by the system. The continuation. A dynamic regenerator works by storing and transferring heat between fluids without violating energy conservation. Heat storage phase. Absorption. The regenerator's rotating or moving matrix absorbs heat from the hot fluid. No heat is destroyed. Instead, it is transferred temporarily in the regenerator material. According to the first law, the heat energy removed from the hot fluid decreases its internal energy. Likewise, heat release phase, desorption. As the matrix moves to the cold fluid, heat release stored it releases stored heat. This increases the internal energy of the cold fluid without any heat loss in the system. So it continues. So continuous heat transfer cycle. The rotating or cyclic movement ensures continuous process of heat exchange. The total heat energy in the system remains conserved. That means none is added or none is lost. Aligning with the first law of thermodynamics. Dynamic regenerators are practical application of the first law of thermodynamics, ensuring that heat energy is reused rather than wasted. This improves efficiency in gas turbines, cryogenic systems, and industrial. So this is a diagram which represents a dynamic regenerative heat exchanger. So the red arrow shows where the hot fluid is, and the green arrows also shows where the movements of the heat from the red arrows into the cold fluid are the direction of the green and blue arrows. So this is also a diagram showing how a dynamic regenerative heat exchangers works or dynamic regenerators work. So let's consider a typical example of a dynamic heat exchanger or dynamic regenerator. Rotary regenerator. A rotary regenerator is a dynamic regenerator where a rotating wheel or matrix is used to transfer heat between hot and cold fluid streams by alternately exposing it to each stream as it rotates. That means as the material or the device rotates, it absorbs heat from the hot fluid and transfer it into the cold fluid, effectively storing the heat within the wheels materials and then releasing it into the other fluid, as I have already said. So how the rotary regenerators works? It operates using a rotating wheels or a rotor filled with a heat storage materials. Hot and cold fluids streams alternately passes through the wheels. Wheels absorb the heat from the hot stream. The wheels then transfer the heat to the cold stream. Continuously recovers heat from one fluid stream and transfer it to another. Heat transfer occurs through the continuous rotation of the heat stored in the matrix. So this is a diagram depicting the work of a rotating or a rotary or a dynamic regenerative heat exchanger. We have a stator housing, exhaust fluid, that means the fluid leaving, inlet fluid. We have an axial seal, a matrix material which stores the heat, and a flow separation seal that prevents one fluid from mixing the other one. This is also a direction on showing how the rotations is happening. So this brings us to the end of our presentation on rotary or dynamic regenerators. So in conclusion, dynamic regenerators are used to transfer heat from one mm, hotter material to a cooler fluid. Thank you.